In the previous video lessons, we learned a lot about the addition of vectors, subtraction of vectors. Now let's learn another topic, scalar multiplication of a vector. What happens when a vector quantity is multiplied by a scalar quantity, by a number, by a real number, or any such scalar quantity? All right, so let's talk about that. What I mean to say that if I have a vector, let's say vector A, all right, let's say vector A has a magnitude of 2 centimeter, all right, magnitude of 2 centimeter, and it is in the direction of let's say east, straight to east. Okay, so by the way, I have already shown here the direction of the vector A. Then what I want to do, I want to multiply this vector A by 2 times, all right, by scalar quantity 2 or number 2. I want to multiply this vector. Then what does this mean? Well, this means that the magnitude of the vector A got doubled. All right, I'm going to say this is somehow like this. Well, okay, so this is the magnitude of A, this is also the magnitude of the A, all right, and if you see, the direction is again same. All right, I will talk later about the direction, but let me first talk about the dimension or the magnitude. All right, so whenever you are multiplying any vector quantity by a number or by a scalar quantity, then the magnitude get changed. All right, so here say here we have 2 centimeter, so now twice of vector A will be definitely in magnitude twice of magnitude of A, which is 2 times 2 centimeter, that is 4 centimeter. All right, so the magnitude of the twice of vector A will be 4 centimeter. Now let's talk about the direction. Okay, so here 2 is greater than 0. So whenever the scalar quantity you are multiplying to the vector is greater than 0, or I mean to say is a positive quantity, all right, that time the direction remains same. Direction remains same means direction of vector A. But if the scalar quantity with which you're going to multiply is negative, all right, or less than 0, then that time direction get just reversed. Direction just get reversed of vector A. All right, I'm going to say in the same time, if you have multiplied that vector A with negative of 2, all right, with negative of 2, then the direction will just get reversed. It will just get changed like this. All right, and everything remains same. I mean, the magnitude will be same, twice of A, but direction will get changed. All right, keep that in mind. So simply I want to say that whenever you're going to multiply a vector quantity by a scalar quantity, then magnitude changes. Keep in mind, magnitude changes, and direction may remain same or just get reversed. May remain same or just reversed. Reverse of the original one, depends on the whether the scalar quantity is positive or negative. All right, and from the scalar multiplication of vector, one more thing we can understand, something like this. Let's say I have a vector A which is 3 times of the vector B. Okay, so what do you understand from this? Well, simply if I'm watching this very straight, then I simply understand that the vector A is 3 times the vector B. All right, so let's say if this is vector A, then I will break it into the 3 part, 1, 2, 3. So let's say vector A is in this direction. So that time, simply from here, I will understand that vector B is just one portion of this. All right, this is the vector B. All right, in direction also, right, it's the same, the direction of A. All right, when A is 3 times the B, then you should understand that the direction of A and direction of B is same. That's what you have to understand. They are both into the same direction. But my brother, you may ask me, hey Anil, why B can be only here? Can't B be here a little far, here like this? And I will say yes, B can be a little far also. B can be here also, you know. It doesn't mean that B should be on this line only. It can be anywhere, but always keep in mind both B and A will be into the same direction. Or this can also be explained somehow like this: both are into the same direction, it means they may be parallel. Right, both are into the same direction, it means they may be parallel. Right, one line is here, another line is here. All right, they are both are acting into the same direction, but they are not touching each other. Then that means such lines are called parallel. Or if they are touching each other, if B is going just over this, then that time they can be shade collinear, or you can say coincidence line. All right, so simply I want to say that when A vector is k times of B, then vector A conclusion of this is vector A is parallel to vector B. Alright, this is what I was trying to deliver you. This is the message I want to say. Alright, keep this thing in mind. This is your note 2 for your brain, and your note 1 was this. So whenever scalar multiplication of a vector happens, then magnitude get changed, alright, and direction remains same or maybe get reversed until and unless k is 1. Alright, if k is 1, then everything will be same, and the condition of parallelism can be defined based on the scalar multiplication of vector. You should understand this. Alright, so whenever you're going to prove that two lines are parallel to each other, just so that one vector is some scalar number of times another vector. Alright, that's only the way to prove two lines parallel in vector algebra. I hope you understand this concept, and if there is any more confusion or doubt, then please feel free to comment below this video. I'll be really happy to reply you back, and please subscribe the channel and don't forget to hit the like button. Bye bye. I'll be back on the next video.